All right, everybody, what's going on? This video, we're going to do double integrals over general regions. Now, if you've been watching these videos, you know in the last video we did double integrals over rectangular regions. These are general regions, and you know it looks something like this. Here's the graph of f, and then here's our general region right here, D. And so, well, let's go ahead and get started. So, you know, basically what we're doing is we're looking for the volume here over this region that's above this region and under this surface here. All right. So, let's see how we do that. It's a little different, so, but it's not difficult. All right, so we have a plane region D is said to be type 1, so we'll have type 1 and type 2 regions. I'll explain the difference. A plane region D is said to be type 1 if it lies between the graphs of two continuous functions of x, that is, the set of all xy such that x is between a and b and y is between g1 of x and g2 of x. So y will be between two functions. All right, where g1 and g2 are continuous on AB. And here's some examples of type 1 regions. So you can see here we've got the axis between a and b. See, our x values between a and b, and our y values are between two functions. And here's another example, and then here's another example. All right. And then if f is continuous on a type 1 region D described by set of all xy such that x is between a and b, y is between g1 of x and g2 of x, then the double integral over the region D of f of xy dA is equal to the integral a to b, the double integral a to b and g1 of x to g2 of x, f of xy dy dx. Okay, so you can see on when we're setting up our integral, this is what we're going to have to do, is set up the integral. So on a type 1 region, we've got our bounds over the x values. See, that's from a to b. And then you can see here we're going on our y values here. You see that? We're going from here to here, and that's from g1 of x to g2 of x. There's our g1 of x to g2 of x. And then we're integrating with respect to y, and then we're integrating with respect to x. That's dy dx. All right. Now, the other thing that you'll probably notice as we're working through these integrals, when the limits that are constants, those are going to always go on the outside over here. Okay, and your functions will go. I mean, you can have constants over here, but you know, you saw that if you watched the last video when we integrated over a rectangular region, but on this general region here where we got two functions, your functions are going to go on this inside integral. The constants, they're going to go on the outside, and you'll integrate with respect to y first, because think about it. Okay, you've got a function in terms of x and y, and you integrate it with respect to y first, and then you're going to take these two functions here and plug them in for y, and see these two functions are in terms of x. And so once you do that, everything will be in terms of x, and then you integrate with respect to x, and you can plug these bounds in. I'll point that out again when we're working the problem. Okay, so if you didn't quite get it then you know, I'll explain it again. All right, then we can also consider plane regions of type 2, which that's the region is the set of all xy such that y is between c and d, and x is between h1 of y and h2 of y. All right, And here's some examples of these regions. So you can see here the bounds here. You see C and D, they're constants. They're going along the y-axis. And then when we go along the x-axis, these are functions. But notice these functions here, they're in terms of y instead of x. Okay. All right. So, and then same thing here. Here's some more examples of them. Okay. So if f is continuous on a type 2 region, D, described by the set of all x, y, where y is between c and d, x is between h1 of y and h2 of y, then this double integral is the double integral, and you can see here how the y coordinates, the y bounds, CD, and then the x bounds, they're these h1 of y and h2 of y. And then notice here we're integrating with respect to x, and then we're integrating with respect to y. Okay. All right. So let's take a look at an example. All right. So we want to evaluate this where D is the region bounded by the parabolas y equal 2x squared and y equals 1 plus x squared. So whenever you're integrating these things, and you have to set up your integral, just go ahead and make a quick sketch of it. Okay, you wanna always do that. All right, so if we make a quick sketch of this, all right, so y equals 2x squared. That's gonna look something like this. And then this is y equals 2x squared. And then we have y equals 1 plus x squared. So that's going to look something like this. Okay. All right. So we got something like this. This is y equals 1 plus x squared. All right, and here's your region D. All right, so hopefully you can see this would be a type 1 region, because look at just think about our x bounds. Okay, can you see that they're going to be from this x value to this x value? We're going to have to find where these two graphs intersect, and then look at the bounds on your y. Can you see it's going to be this function and this function? All right. So first thing we need to do is we need to find out where these two graphs intersect. So we've got 2x squared equals y plus x squared. So x squared equals 1. So x is equal to plus or minus 1. So you can see we got -1 and we got 1. So this point here is -1 what? Well, how do we get the y value? Well, just plug it into either this one or this one. Well, if I plug -1 into here, that's going to be -1 squared is 1 times 2 is 2. And then same thing here. This is the point 1, 2. Okay. All right. So let's look at it. Let's set up our integral. So we have the integral over D from x plus 2y dA is equal to the integral. Okay, so we're with the type 1, and notice our functions, the function that's on top, that's a function in terms of x, and then we've got a function in terms of x on the bottom. See, y equals 1 plus x squared, y equals 2x squared. But now when we go, that's when we're going along the y-axis. Okay, you can see it's bounded by these functions here. Now, when we're going along the x-axis, you can see, well, we've got a point here. This is -1 and this is 1. So we know we're going to have -1 to 1. And then for this integral, it's going to be what? this is actually what, g1 of x, and this is g2 of x, right? See up here, your g1 of x and your g2 of x is on top. See, y is between g1 of x and g2 of x. g2 of x is the larger function. All right. And so that's going to go from 2x squared to 1 plus x squared of x plus 2y. And then what are we integrating with respect to first? Now notice our bounds here are in terms of x. We're going to integrate with respect to y first and then x. See up here, when our, when our bounds were in terms of x, we integrated with respect to y first. And look down here, when our bounds here were in terms of y, we integrated with respect to x first. Okay. All right, so let's see what we get. So we're going to get -1 to 1, and we're integrating with respect to y first, so that's xy plus y squared. And that's from 2x squared to 1 plus x squared dx. All right. All right, so now we just evaluate this. We have to plug this in for y, and then minus, and then plug this in for y. And so that's going to be -1 to 1. And that's going to be, let's see, that's going to be x times 1 plus x squared plus 1 plus x squared squared. So I just took the 1 plus x squared, plugged it in here for y, and then plugged it in here for y, and then minus, and now I plug the 2x squared in. So that's going to be x times 2x squared plus 2x squared squared. And then that's dx. All right. All right, so let's move right along. And so now, you know, this is probably one of the parts we don't like as much, because now we gotta do all this and kind of simplify it down. And so this is going to be -1 to 1 of x plus x cubed plus 1 plus 2x squared plus x to the 4th minus, I'm distributing the negative, so minus 2x cubed minus 4x to the 4th dx. And that's going to be -1 to 1. And so now we're going to combine like terms. That's -3x to the 4th. Okay, so that takes care of that one and that one. And then we've got minus x cubed. So that takes care of that one and that one. And then plus 2x squared plus 2x squared plus x plus 1 dx. All right. So now we get to integrate this. And so that's going to be -3/5 x to the 5th minus 1/4 x to the 4th plus 2/3 x cubed plus 1/2 x squared plus x, and that's from -1 to 1. All right. So let's see. All right, and now we evaluate it. And so that's going to be -3/5 1 to the 5th minus 1/4 1 to the 4th plus 2/3 1 cubed plus 1/2 1 squared plus 1 minus, and now we plug the -1 in. -3/2 -1 to the 5th minus 1/4 -1 to the 4th plus 2/3 -1 cubed plus 1/2 -1 squared plus -1. And then once you do all that, you end up with 32 over 15. All right, and there's your answer. All right, so the thing here is you're gonna have to be able to set these things up. Okay. So let's look at this next example. In this next example, we are going to actually work it. Well, you'll see. We're going to work it both ways. There's some out there where you can work it as a type 1 or a type 2. Okay, and this is one of them. And we're going to actually set it up both ways so you can see. Hopefully everything will make more sense after this. All right, so find the volume of the solid that lies under the paraboloid z equals x squared plus y squared and above the region D in the xy plane by the line y equals 2x and the parabola y equals x squared. All right, so just like I said before, let's draw a graph. So it's going to look something like that. All right, so let's see. We got this, and then we got this line here. All right, so this is y equals 2x, and this is y equals x squared. All right. So let's first set it up as a type 1. Oh, and the other thing too, we know here we're going to set it up as a type 1, and I should have drawn this in there, but this, you can draw an arrow there. So if you're going for a type 1 region, your arrow is going to be up and down here, so you know you're going from this function to this function down here. That can help. And I should have drawn it on there, but it just, I guess, just slipped my mind. But let's look at this. Let's set this up as a type 1 region. And so we can put our arrow there. Okay, so it's a type 1. So we're going from 0 to, we're going from 0 to this value here where these two graphs intersect. So let's find where they intersect. So I got x squared equals 2x. So x squared minus 2x equals 0. X times x minus 2 equals 0. X is 0 or x is 2. And so it intersects there. Now, what's this point? This is the point 2 what? We'll take the 2 and either plug it into x here or here. So when I plug the x in, I get 4 for my y value. All right. All right, so setting up as a type 1 region. All right, so we're going to have, let's see, we got x squared plus y squared. Okay, so there's our function. That's what we're integrating over that region. And so this is going to be what? 0 to 2. Okay, 0 to 2. And then what's the bounds on this one? Well, it's, see, this function and this function right here. Okay, so this one, okay, so this one's on bottom. So this one is g1 of x. And this one, see how it's on top? This is g2 of x. And so we're going from x squared to 2x of x squared plus y squared. And then it's what? dy dx. See how the x is right on the inside here? We're going with integrating with respect to y first. All right. All right, so let's see what we get. So we got 0 to 2. Now we're integrating this, and we're integrating with respect to y. And so that's going to be x squared y, right, plus 1/3 y cubed. And that is going from x squared to 2x dx. so let's see what that gives us. That's going to give us 0 to 2. And we're plugging the 2x in for y, so that's x squared times 2x plus 1/3 times 2x cubed. That is a 3 right there. All right, minus, and now we plug the x squared in. So that's x squared times x squared plus 1/3 times x squared cubed. So I took the x squared, plugged it in for, oh, that's not an x cubed there. This should be y cubed. All right, so sorry about that. That should be a y. You know, you get in the habit of writing x all the time. So, but it's y. The antiderivative of this is 1/3 y cubed. I put an x instead of a y. All right. All right. So now, and that is dx. And so now we got to simplify this out. So that's 0 to 2. That is going to be 2x cubed plus, now that's going to be 8 over 3x cubed minus x to the 4th minus 1/3 x to the 6th dx. All right. So let me make sure I didn't write down a stupid mistake. Okay. And now let's go ahead and combine like terms. Okay. Make it a little easier to do. So this is going to be negative 1/3 x to the 6th minus x to the 4th plus 14 over 3x cubed dx. So I could combine the x cubes. All right, so now let's go ahead and integrate this thing. So that's going to be negative 1 over 27. No. Negative 1 over 21 x to the 7th minus 1/5 x to the 5th plus, and that's going to be what? Is that going to be 7 over 6 x to the 4th? If I multiply this by 1/4, the 4 and the 14 cancel. I'm left with 7 and 2 down here. 2 times 3 is 6. And that's from 0 to 2. And so now we get negative 1 over 21 times 2 to the 7th minus 1/5 times 2 to the 5th plus 7/6 times 2 to the 4th minus, and now these are the ones I like. So I plug the 0 in, and you can see we'll get 0 everywhere, so that's just 0. And so that's going to give us an answer of 216 over 35 once you calculate it. Okay, so that was that problem. That was setting it up as a type 1 region. Now remember, I also told you we can set this up as a type 2 region. And you know, and it doesn't make any difference. Doesn't make any difference which way you set it up, because I mean you're going to get the same answer either way. Now you may, I don't know, you may see it on this one or not. You may find that one way is a little more tedious or complicated than the other way. Okay, so which way's the best? Is it going to be best to do a type 1 or a type 2 region? You don't know. Okay? That's why you'll have to actually practice. Okay? You practice these things and work them, and sometimes you may be able to see, well, this one's going to be a little easier than this one, or this one's going to be a lot easier than, this way. So, all right, so let's set it up as a type 2. And see what happens. So let's go ahead and let's draw our sketch again. Okay. And we know this intersected at, what was it, 1, 2, I believe? No, didn't intersect at 1, 2. It intersected at 2, 4. Remember, we found that earlier when we worked it as a type 1. And I don't know, I keep hitting these little icons in the tray. And we're setting it up as a type 2. So we're going this way. So, you know, our bounds, the bounds on the y-axis, okay, the bounds on the y-axis, those are going to be constant, and the bounds on the x-axis, those are going to be functions in terms of what? In terms of y. All right? All right, so let's look at this. So we're going from here to here. So this is what? 0 to 4. All right, that's on the y. Now, what about these functions here? Well, you know we have y equals x squared, and we have y equals, what was it, 2x? Okay. So, but I need these functions here in terms of y instead of x. And so this tells me that x is equal to the square root of y, and this one tells me x is equal to y over 2, right, if we solve. And so this, we've got x is equal to the square root of y. If it were, yeah, I know it's plus or minus, but if it was the minus one, we would be dealing with this side over here, and we're just dealing with this side, so it's the positive one. All right. And this one is x equal y over 2. All right. We're just writing them in terms of y instead of x. All right. So what is this? This is what? h1 of y, and this is h2 of y. And that is not correct. I told you wrong. I guess I was thinking about the G1 and G2. This is H2 of Y, and this is H2. I did it again. This is H1 of Y. Okay, so just remember that the H2 is the function on the right. The H1 is the function on the left. Okay, see how this one's on the right-hand side and this one's on the left-hand side? All right, so let's set up our integral. Some d, and what was our function was what? Yeah, x squared plus y squared dA. Okay, see, I'm still using all this from up here. There's our function. There's y equal 2x and y equal x squared. That's where I'm getting all that from. All right, so this is going to be the integral. So we're going to go from 0 to 4. And then we're going from what? H1 to H2, right? All right, so that's going to be y over 2 to square root of y. So we're going from H1 to H2. And that's x squared plus y squared. And then what are we integrating with respect to first? See, our limits here are y. We're integrating with respect to x, and then y. All right. And so let's see what that gives us. That's going to give us 0 to 4. And we're integrating with respect to x. That's going to be 1/3 x cubed plus xy squared. And that is from y over 2 to square root of y dy. All right, so we need to evaluate this in here. And so that's going to be 0 to 4. And that is going to be 1/3 times square root of y cubed plus square root of y times y squared minus, okay, so I just took the square root of y and plugged it in for x, All right. And now I'm going to plug in y over 2. So that's going to be 1/3 times y over 2 cubed plus y over 2 times y squared and dy. All right. So that's going to give us 0 to 4. And this is going to be 1/3 y to the 3/2. All I did, I just changed it to exponential form, from radical form to exponential form. Remember how to do that. And then plus, so this is y to the 1/2, right? This is y to the 1/2. So when we multiply, we add exponents. So 1/2 plus 2, that's going to be y to the 5/2 minus, and that's y cubed over 8, which is going to be y, that's going to be, let's write it like this. That's going to be 1 over 24 y cubed. And then minus, distribute that minus 1/2 y cubed. And that is dy. And so let's go ahead and combine like terms. And so I got 0 to 4. You can see I can combine the y cubes. And that is going to give me what? Let's see. All right, so that's going to give us, let's see, negative 13 over 24 y cubed. That's combining that. And then plus 1/3 y to the 3/2 plus y to the 5/2 dy. All right. So let's see what that does. That's going to give us, see, I got enough room. I'll come down here. So that's going to give me negative 13 over 96 y to the 4th, right? Because that's 4, then divide by 4, 24 and 4 is 96. And that's going to be plus, all right, so that's going to be 5/2. All right, let's see, yeah, to the 1 to the 3/2, so that's going to be y to the 5/2. And so I've got to do 1/3, multiply this 1/3 by 2/5, so that's going to be 2 over 15. And then plus, and then this one, that's going to be y to the 7/2, and that's going to be 2/7 in front of there, and that's 0 to 4. All right. And so now we're going to get negative 13 over 96 times 4 to the 4th plus 2 over 15 times 4 to the 5/2 plus plus 2 over 7 times 4 to the 7/2 minus, and then look, when we plug the 0 in, that's just going to give us 0. And so we end up with 216 over 35. And that's just what we ended up with here. So, you know, like I said, which one was easier? I mean, in this case, they were kind of similar, but I would have to say probably the type 1 might have been a little bit easier, seeing, you know, so we didn't have to deal with the fractional exponents. Okay, so, you know, how do you know? Well, if you go and set these, when you set this part up right here, okay, so when you set this part up, okay, you can see you got a square root here, and you know you're going to have to plug it in here. So that might just kind of be, you know, so if you do that first, you may say, well, let me go set up the other one and see what it looks like. Okay. All right, so let's look at this example. All right, so let's look at this one. So we want to evaluate the integral over the region dxy. D is the region bounded by the line y equal x minus 1, and the parabola y squared equals 2x plus 6. All right, so let's make a quick sketch of this graph here. All right. And we're going to set it up both ways, but we're going to set it up as a type 1 and a type 2, but the type 1, we're not going to work that one out. Okay, I'm just going to set it up. And if you're bored later on after you watch this video, you can write it down, the type 1, and you can work it out. All right, so we've got all right, so if we graph this, we know this is a parabola that opens to the right. Okay, and we know we're going to be, we'll be, I think, let's see, right here. Because look, if we can actually solve this for x if we wanted to, which here we're at -3, and it's coming around like this and like this. Okay, and so then we have the line y equal x minus 1, so that's going to be this line here. This is y equals x minus 1. All right, now we're gonna set this up as a type 1. So that means our bounds, we're going this way, right? You see that? We're going like this. Now, you may see it now, but if not, I'm gonna point it out. So our functions need to be in terms, our equations need to be in terms of x, right? Need to be in terms of x. So we need to, so which, that's fine here. We got y equal x minus 1. So what about this? What is this in terms of x? Well, if I take this, y squared equals 2x minus 6. Well, I mean, it is in terms of x, but I guess I should have said it's not y equals something in terms of x. We don't want y squared equals something in terms of x. So this is y equals plus or minus the square root of 2x, and it's plus 6. So you can see here, this is y equals the square root of 2x plus 6, and this one down here is y equals negative square root of 2x plus 6. See that? And we do need to find out where these two graphs intersect. And so, you know, you can set them equal to each other, I guess, but I think maybe the easier thing to do would to be maybe just take this x minus 1 and plug it in for y, because isn't that what y is? So we've got x minus 1 squared equals 2x plus 6. So that's x squared minus 2x plus 1 is 2x plus 6. So x squared minus 4x minus 5 equals 0. So x minus 5, x plus 1. So x equal 5 or x equal -1. So this is going to be the point -1 something, and this is going to be the point 5 something. So we're right here at -1, and we're here at 5. And we're going to get the y values also. So you just take the -1, take the 5, you can plug it into either one of them. Let's plug it into here. So -1 minus 1, that's -2. And then 5 minus 1 is 4. All right, so there we go. All right, so we're getting there. Now, let's look at this. So I can see the curve on top, okay? I can see this is G2 of x, right? But look at this, and I'm going to highlight this with a different color. Look at this, if you can see that green right there. Look at this. See? look at this part. See how this function here is on top, and then this function is on bottom. You see that? But only from -3 to -1. And then from -1 to 5, this function right here is on bottom. So it changes. Okay? So what is our curve on the bottom, our lower boundary? Lower boundary. Our lower boundary curve, which is what is that? What's our lower boundary curve? That's g1 of x, right? That's our lower boundary curve. See, this is this right here. That's g1 of x. Well, that's equal to what? It's equal to this one, the negative square root of 2x plus 6. That's if x is between -3 and -1. -3 and -1. But it equals this one. See, this one's on bottom. So that equals, what was it? X minus 1. X minus 1 if x is between -1 and 5. If x is between -1 and 5. So you can see, there you go. Okay? There you have it. So now, what would be our integral? And I'm going to erase this so we can write it up here, so I'll be able to, so we can see everything while I'm writing it down. All right. So we've got our double integral xy dA. All right. See, there it is. That's what we're looking for. That is equal to, okay, so let's look at this. So it's like we're splitting this. Let me find a color to do. So it's like we're splitting it. Right here we got two different regions, don't we? And so that's going to be what? -3 to -1, -3 to -1, and then what? And then there's G1. See, this is our G1. That's going to be negative square root of 2x plus 6 to square root of 2x plus 6, xy, and then that's going to be what? dy dx. All right? And then plus, and I'm going to come down here and do the plus. Normally I would put it right there, but I don't know if might run off the screen. Well, let's just do it. Let's try it. All right. And so then we're going to go from what? Now we got to do this region. So that's -1 to 5, -1 to 5. And then we've got what? It's this region here. But see, just to here, it's this region, which is, that's on top. So that's square root of 2x plus 6. And then the G1, that's this part. That's the x minus 1. X minus 1, and that's xy. And then that's going to be what? dy dx. And I managed to stay on the screen. And so then you would have to integrate both of those, which you can see that's quite a bit of work there. Okay? So that's not what we want to do. Okay? We don't want to have to do both of those. And you know, you might set this up, you know, you set it up first as a type 1. You set that up and say, oh, I don't want to work that. That's too much work. So let's try setting it up as a type 2. Now, is the type 2 going to be easier? I don't know. We hadn't set it up yet. It probably is, but let's see. All right. So let's draw it again. Okay. All right, so I just paused it while I redrew it. Well, I didn't redo it, I just erased the stuff. And I had to erase all the other stuff too that I set up, but you can go back and watch that again or look at it again because I didn't have enough room to work this part. All right, so you know, we set up to where they equal. We found those points there. We found these points here. All right, so we're going to set it up as a type 2 region. Okay, we're going to set it up as a type 2 region. And so that is like this. Okay. All right. So that means what? That means we're going to have to do what? We're going to have to get these graphs here in terms of y. Okay? So I have y equals, and you can see on the y, that's going to go from 4 to what? From -2 to 4, right? See, that's my y values. And so I have y equals x minus 1, which that tells me y is equal, which that tells me x is equal to y plus 1. And then I have y squared equals 2x plus 6, which that gives me x is equal to 1/2 y squared minus 3 when I solve it. Okay. All right, so here I have x is equal to 1/2 y squared minus 3. And this one I have x is equal to y plus 1. All right. And keep in mind, this is h1 of x. And this is h2 of x. All right. All right, so let's set this thing up. So I've got d, and that is xy. All right, so I'm going from what? All right, so my y values, that's -2 to 4. So -2 to 4, and then we're going from what? H, and I have no idea why I wrote h1 of x. That's h1 of y and h2 of y. So h1 of y, that's 1/2 y squared minus 3, and h2 is y plus 1, and that's xy, and then that's going to be what? Dx dy. All right, so we've got it set up. Okay, see, it's not really that hard. You know, just draw it out, type 1 or type 2, and, you know, draw your arrow in there, and that lets you know, okay, here's my functions. Okay. All right. So this is going to give us -2 to 4, and we're integrating with respect to x, so that's 1/2 x squared y, and that is from 1/2 y squared minus 3 to y plus 1 dy. So now we've got to plug all that in. This right here, to me, this is the most tedious part here. This is where you really got to be careful when you're doing all that, you know, combining all those terms and simplifying it. You need to really take your time because it's easy to mess up. And so we've got -2 to 4, and that is going to be 1/2. So we're plugging this in for x. So that's y plus 1 squared times y minus, and then we've got 1/2 times 1/2 y squared minus 3, and that's squared times y and dy. All right, so let's see what this gives us. -2 to 4. So that's going to be 1/2 y. I'm just putting those together, and that's going to be y squared plus 2y plus 1 minus, and that's going to be 1/2 y. And that's going to be 1/4 y to the 4th minus 3y squared. Because see, that's going to be 1/2 and negative 3. That's negative 3/2. Negative 3/2 minus 3/2 is 6/2, which is just 3. Okay. And then that's going to be plus 9. And that is going to be dy. And so this is going to give us negative 2, 4. So basically what I'm going to do here is I'm going to distribute this to this, distribute this to this, and then I'm going to combine like terms. And after I do all of that, that is going to give me negative 1/y. No, that's not 1/y. Negative 1/8 y to the 5th plus 2y cubed plus y squared minus 4y dy. And then we integrate that. And so when I integrate that, that's going to give me negative 1/48y to the 6th plus, that's going to be 4 divided by 4, so that's 1/2 y to the 4th plus 1/3 y cubed minus 2y squared, and that's from negative 2 to 4. All right, and you know, plug the 4 in, plug the negative 2 in. At this point, you should be able to do that by now. I showed the work in earlier problems. So for this one, that's going to be 36. All right. All right, so let's look at this next example. So we want to evaluate this iterated integral, double integral 0 to 1, x to 1, sine y squared dy dx. Now, so let's look at this. Okay, let's look at it. So I've got this, and I want to integrate this with respect to y. So I've got sine y squared, integrate that. Well, that's not going to happen. Okay, you can't integrate that. Okay, so what we need to do is we need to change the order. Okay, we need to change the order that we integrate. All right, so how do we change that? Well, can we just do this? Can we just go x1, 0, 1, sine y squared dx dy? No, you can't do that, because remember what I said earlier, you're going to have constants back here. There's going to be numbers on these bounds back here. So you can't just swap the integrals and swap that. You can't do that. So what you need to do is you need to kind of sketch it, sketch the region. Okay? So, you know, you're looking at this right here, this 1 and this x. And you know, this is a type 1 region. We got the dy here, we got the 1 and the x here. So we know this right here, this is the line what? That's y equals 1. That's 1. It's line y equals 1. This is y equals x. That's just a straight line there, right? And the x values, they're going from 0 to 1. So this is what we have here. That's our type 1 region. This is type 1. So what we want to do is we want to change the order. We're going to change it to a type 2. So let's look at we already drew it here. So let's look. We know that's 1, that's 0, and we know that's 1, and we know this is y equal x, right? But we want to change it to a type 2. Okay, so what would we have? Well, remember, we're changing it to a type 2. So these bounds on the outside, that's going to be our y values there. That's from 0 to 1, right? And then we're going from what? From x equals 0 out this way to what? To this line right here, right? This line, y equal x. Okay, well, what's x? That x, that's y. Okay, remember, I gotta have this here in terms of y. See this line here? That's my g. That's my h1 of y, and this line right here is my h2 of y. Okay, so it needs to be in terms of y. Remember the type 2 functions. And that's going to be sine y squared, and that's going to be what? Dx dy. All right, so hopefully all that's making sense. Okay, so let's integrate this. So that's going to go from 0 to 1. So remember, I'm integrating with respect to x. So this is just going to be x times sine y squared dy. That's going from 0 to y dy. And so we've got 0 to 1 of, we're plugging the y in for x. That's y sine y squared minus 0 times sine y squared, right, dy, which this is 0 to 1 of y sine y squared dy. Then this right here just goes to 0. And now I can integrate that. That's what? That's u substitution. All right. So I'm going to let u equal y squared. Du is 2y dy. Now, I don't know how you do the u substitution, but I may do it a little different than some of the other teachers do, but this is how I always show it. So we know for the y squared, we're plugging u in, right? And then we need to plug the du in. And you can see here I have y and dy. See the y and the dy? What am I missing? I'm missing a 2. So I can multiply by 2, and then I need to come out there and multiply by a half. All right. And so that's going to give me 1/2. And that's going to be sine u du. So I plugged u in for y squared, and for the 2y dy, I plugged in du. Now remember, we have to see, we're in terms of u now, so we have to change our limits. And so do you remember how to do that? Whoop. That's not what I want. So remember, to do that, we've got u equals, so what I have to do is I have to take this bound and this bound, plug it in for y. You see that? So I'll plug 0 in for y. That's 0 squared, which is 0. And then u equals, and then I plug the 1 in for y. So that's 1 squared, which is 1. So in this problem, they're both, it's 0 and 1. But just keep in mind, this 0 and this 1 is not this 0 and this 1. These are y values. These are u values. That's not going to work out every time where they're the same. It just so happens that it does in this problem. Okay? But just know, when you do the u substitution and you change your variable to u, you have to plug this and this in for y to get what the u value is to change your limits. Okay? All right. So now that's going to give us, so what's the antiderivative of that? Negative cosine. So that's negative 1/2 cosine u from 0 to 1. So that's going to be -1/2, and that's going to be what? Cosine of 1 minus -1/2 cosine of 0. And so that's going to be -1/2 cosine 1 plus, so cosine of 0 is 1. 1 times -1/2 is -1/2. Negative is positive, so that's +1/2. And, you know, I guess you can either plug it into your calculator or leave it like that. Whichever one would be fine. All right, so let's look at this. We've got some properties of double integrals, and we have one example left to work, and we'll be done. All right, so this property right here is just showing us that if we have, you know, several functions added together, we can do them each individually. And then this, we can pull the constant outside. And then this one says that if we have a function f of xy is greater than g of xy for all points in D, then the integral of this function is greater than or equal to the integral of this function right here. And then this one is just telling us that we can split the region into two parts, which, remember, we did that on that one problem. We set it up. We didn't work it out, but we set it up. We had that region split up into two parts, and we actually did that right there. And then if we integrate the constant function, f of xy equals 1. So if we have the constant function 1 over a region D, we get the area of D. That gives us the area of that region D. And then we have this: if m, little m, is less than or equal to f of xy, which is less than or equal to big M for all x, y, and D, then m times the area of the region is, or basically what it's saying is this integral is between little m times the area of the region and big M times the area of the region. All right. And so that's what we're going to do an example. We're going to do an example showing this right here using that property there. So let's see what we've got here. It says use the above property to estimate the integral. So you're not going to be able to integrate that. You know, are you going to be able to integrate with respect to x first? Or are you going to be able to integrate with respect to y first? So what we're going to do is we're going to get an idea, and we'll be able to say, okay, it's between this value and this value. So use the above property to estimate the integral. This, where D is the disk with center, the origin. That should be D. The center's at the origin. And it has a radius of 2. All right. So let's see what we have here. How are we going to go about solving this? Well, let's write down some things we know. Some things we know about this up here. We know that sine is between -1 and 1. And we know that cosine is between -1 and 1. And so that would tell us what? Well, and that's not sine. That's not cosine x, it's cosine y. So that would tell us sine x times cosine y is less than or equal to 1, right? Because if you multiply them, if they're both in between -1 and 1, when you multiply them together, you're not going to get anything larger than 1 or larger than -1. All right, so we've got that. So hopefully you agree with all that. If you don't, well, it's true. All right. And because the natural exponential function is increasing, okay, because it's increasing, well, we can write this as e to the -1 less than or equal to e to the sine x cosine y less than or equal to e to the first, right? I just do e raised to each one of those. And this is going to hold true right here. And so basically what I have is 1 over e less than or equal to e to the sine x cosine y less than or equal to e, right? Now, notice right here, that's little m. This is big M. See, I've got my f of x, y. See that? Where is it? See, I've got a f of x, y that's between m and little m. This is the part that I've set up right now. Okay? See that? I've got my f of x, y is between little m and m. And so what are we wanting to do? We're wanting to know what is this integral here. We're wanting to know the integral of f of x, y over d. Okay, well, what is that? Well, that's the little m times the area of the domain and big M times the area. Did I say domain? I meant times the area of the region. And big M times the area of the region. Okay, so what is the area? What is AD? What is the area? Well, what is that? It's a disk with radius 2. So a circle with radius 2. So that's what? Pi times r squared, which is 4 pi. And so I can do 1 over e times 4 pi, right? Isn't that what it says? Little m times the area, big M times the area. And what's in between that? The double integral, the integral over that region. Okay, and that's less than or equal to, now see, I'm multiplying it by the area of the region. So that's going to be this, e to the sine x cosine y dA less than or equal to e times 4 pi. Okay, and so, I mean, I'll just clean it up a little bit. I'll just write the e under there. dE to the sine x cosine y dA 4 pi e. And so there you have it. This integral is between these two values. All right. So I hope this video helped. I know be careful, because I know I did it a couple of times in the video, but just be careful that you write an x when you're supposed to be writing an x, and you're writing a y when you're supposed to be writing a y. I know you're so used to when you're dealing with functions that it's usually y equals something in terms of x. You're used to writing it all in terms of x, but you need to be careful here and pay attention to that when you're writing it down. I mean, I even did it in the video some. It's going to happen, okay? But just take your time and do it. But like I said, I hope the video helped. Check out my other videos. Give me a like, share, and subscribe. Thanks for watching, and I'll see y'all in the next one. Later.